Welcome to week 9 on radicals. We're in the home stretch now. Radicals, I think, is going to be a little bit easier of a concept, and these are the things that we are going to cover this week. We need to know a little bit about our terminology. We need to know the laws of radicals. We need to figure out how to simplify them, how to solve the radical equations, and then an application problem using Pythagorean theorem. That is the goal for this week. This is a radical sign, also known as a square root. Or the radical symbol, or the square root sign. It's going to be used to cancel out squares. Thus it's called a square root. Now a radical doesn't exist by itself. You have to have a number underneath here. The number underneath is called the radicand. The radicand can, the radicand can. Whenever you see a radical, this is the inverse operation of squaring. Everything that we do in math land, we learn how to undo it. We first learned how to add, and then we learned take away. We learned multiplication, then we learned division. Well, we've always kind of learned the square, but we never really learned how to undo it. And that's what we get to do this week. So when I see something like this, it's called the square root of 16. We need to remember that the key thing that this is not is division. We are not ever taking that radicand and dividing it by 2. We have other symbols to mean that. We would not use this ugly little thing. It kind of looks like a long division sign with a boot on the end. That's exactly what's happening. We're wanting to boot out squares, which is why it's called a square root. Okay? So when we see something like this, the square root of 16, we're asking ourselves, what number times, and this is key, itself is 16? The answer to that is the answer to what is the simplification of the square root of 16. So the square root of 16 we know is 4 times 4, so the square root of 16 is 4. Now we've used the square root symbol because the square root symbol is telling us to answer this question. Because we answered the question, we used the symbol, which means that it's not there anymore. And the answer is simply 4. Now 16 was a nice one because it's a perfect square. Okay. We probably want to get fairly familiar with our perfect squares. We may be fairly familiar with a lot of them from our factoring chapter. That was chapter 5, week 6, in which we had the difference of perfect squares was one of the things that we factored. And so our perfect squares are 1, one's a perfect everything, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, 225, 256, x squared, etc. That would be your first 16. Those are probably the ones that we would be using the most often. So make a list of those so that you are familiar with them, so that you can recognize your perfect squares in case it comes up underneath a radical. So remember, a radical or the square root is just canceling out the idea of a square. So we're finding out what number times itself would give us that. With anything in math land, we have laws to go along with it so that we can follow the correct rules and have a joyful visit in math land. We have 2 radical laws. The first is that of a product. So if I have the square root of a product, remember a product means multiplication. So I have 2 numbers being multiplied together underneath my radical. The product law allows me to separate those into 2 radicals that are still being multiplied. This helps us with some simplification that we'll show you in just a bit. Now, if there's a law about a product in math land. Because division is really multiplying by a reciprocal, division's the same thing as a product. If there's a law in the product, there has to be a quotient law as well. The quotient law is very similar. If I have a quotient, we like to call them fractions. Underneath the radical, we can write that as two separate radicals. The a stays in the numerator, the b stays in the denominator. Okay. Now, technically in Mathland, it's not simplified to have a radical in the denominator, so we're always hoping that that b value is a perfect square. If it's not, we'd have to go through a technique called rationalizing the denominator. This might be important for you to go through in your book because there's definitely, I think, one problem either on the quiz or on the final exam that talks about this. So you definitely want to review rationalizing the denominator from your textbook. Rationalizing the denominator is found on page 645 in your book, and then a more complicated method for a little bit harder types of rationalizing the denominator is on page 655. It's just multiplying top and bottom by a 1 in order to get rid of the radical in the denominator. We're not going to focus on that here as it's just one problem. But the quotient law and the product law will help us do some simplifying. That comes up next.